So what I want to do here is that I want to look at this example and go through the details of what we're looking at. Okay. So again, this is a fairly nice example, but I want to expand on this just a little bit here. And the first thing that I want to look at here is that I want to write a short description of this motion of this object. So I want to convert this dots into effectively a story with its motion diagram. So in this case, let's look at the very first one here. What am I actually seeing here? Is that in this image, let me just grab the image here. So if I look at the first image and I paste this, what am I actually seeing in this image here? Well, what I'm seeing here is that I'm seeing that I have my point 0, and from my point 0, I know that it's going to stop here. So if I was to draw a motion diagram for this thing, note that according to this image, 1 cannot draw a vector on point 0. And the question is why? We do not know the interval before 0. So the only thing we can do here is that we can draw an arrow at point 1. So here we go. So I'm going to come over here and I'm going to say that this is 0, this is 1. Now I start my process here. What's my motion diagram going to look like? Well, you could imagine here is that I'm driving my car, and I'm seeing here is that at point 5, that's a stop sign. So I'm assuming that right here, there is a stop sign that I have to stop for because I'm a lawful citizen. So in this situation here, now I could start my process as we did before. I could go in and I could say, okay, here's my interval. And I could come in and I could say, this is my, let me draw this 4 squares. So that's my velocity between interval 1 and 0. And now if I continue to move in that direction, then I bring this down, and then I'm going to say that it is now slowing down. So this is between 1 and 2, and then I'm going to look at this interval, and that's going to tell me that this speed here is then going to be slower, and that's the speed between 2 and 1. So again, if I wanted to really pay attention to size, I'm going to have to draw these accordingly to scale here. And how do I know what these sizes are? It's all relative here. Now, when I grade you, I am not going to take a ruler out and start measuring things unless they look all the same to me. If they look all the same to me, then I'm going to take points off because that shows constant velocity, not changing velocity. So then again, if this is 3, I bring my 3 down here, and then you could see here that this is now going to be 4. And so that then gives me my speed between 4 and 3. And if I continue on, you know what? I put an arrow right there, which I should not have. Look at that. I have already screwed up. Look at this. Look what I did right here. Look at the distance between 1 and 2. That's 3 squares. Look at the distance between 2 and 3. That's 3 squares. That's wrong. what I should have done is that I should have put this at 2 squares. Okay, so now that's correct. So then if I go to 4, you could see here is that this is 4 to 5 here. Now we got to be careful here, because now what you're seeing here is that I have this distance right here. But what happens at 0.5? It stops. So there is no arrow at 0.5. So right here, there is no arrow since it stops. That would be the motion diagram right there. So now let's look at the next one here. The next image that we have is this guy. And what I'm seeing here is that you could see that this starts right here. So if this starts, what am I actually seeing here? Well, first of all, we can see here is that all the dots have equal spacings. Which immediately tells us that we now have constant speed. And
Hey,
so what we're seeing, yes?
can I ask a question?
Of
Sorry.
course you can.
So in your V1 interval, I just noticed that from the red to the blue, you jumped from 5 spaces
Oh,
to
I
3
thought I
spaces?
drew 4.
Okay, so that is supposed to be just the same, like the correlation of just going down by 1 each time.
Yeah, that just to be consistent. Yeah.
Okay, just wanted to make sure I was correct on that. Thank you.
Yeah, you are correct. Thank you for the help. So now if I look at this guy here, that means here that I have to be changing directions here. So in this case here, so now if I start to look at this thing, I could then come in here and you could see that I am driving east. And as I drive east, I am now moving at a constant speed. Uh-oh, there's some funky thing going on here. It's trying to make my arrows pretty. And you could see here is that there's a change. Now, you know what? I'm going to come back here. And so when I look at this thing, what I'm going to try to do here is that I'm going to try to draw a line that's smooth all the way across these guys. Now, I know that calculus is not a prerequisite for this course, but the definition is of velocity is it has to be tangent to the point on the curve. So if I'm drawing these things, then that means I have to be tangent at that point. I have to be tangent at that point. So as I'm drawing these, I'm always trying to be tangent to that one point on the curve. And then eventually you could see here is that now I'm just going straight at constant velocity here. So what am I seeing here? I'm seeing 2 intervals. What are my intervals? This interval from here to, I don't know, maybe to here. I would say that from this interval from here to here, I am changing velocity. So why am I changing velocity? Because I'm changing direction. So I start driving east, and then I make a left-hand turn to go which direction? West. And as soon as I start moving west, in this interval from here to here, I'm now moving at a constant velocity right there. So to get practice in drawing these things, let's see if we can get into a little bit more tricky. No, let's leave it right there. I'm not going to expand this one, but I'm going to try a different question here. Okay, so here's one question that I want to ask you here. Okay. So now I'm going to give you an example, which is not listed. So here's what we find here. I'm going to give you a series of little pictures, and then I want you to draw the motion diagram for this jogger. So the first thing that you want to pay attention is that you have a jogger running east. At a steady pace. Okay. Now what's going to happen here is that she develops a cramp and stops at a bus stop. So as you have this crank here, this cramp in your leg, it turns out that you can stop right away because the bus stop is right there. Now, what you're going to find here is that she gets on the bus heading west. And then what you're going to find here is that she arrives at home. Now note, when you're looking at this, I'd like to think that there's a clear image that's being portrayed right here. But the question that I have for you is, there's a lot of assumptions here. There's a lot of assumptions. So let's start drawing the motion diagram for this situation here. So what I'm thinking here is that assume that she starts running from her home and that the bus takes her back to her home. So the assumption is that in this situation, the starting and ending distances have to be the same. So here's what I know here. We're going to say that, let's say that this is the point where she runs from home. So how does she run? Well, all we know is that she's running at a steady pace. Can she instantly start running at a steady pace? No, she cannot. So what has to happen? She has to speed up. Right? There's some speeding up that goes on here. We got to be careful now. Okay? So now let's look at my intervals. And I don't think we're going to finish right here. Okay? So this is 0. Oops, I made a mistake already. So this is 1. This is 2. And now this is 3. Okay? So now let's look at our arrows. There's no arrow at 0. Is there an arrow at 1? Yes. So is the arrow at 2 smaller, the same, or longer than at 1? What would be your guess? Well, look at the intervals. If I look at the interval, if I compare that distance to that distance, you could see that that distance is longer. So then check this out. That means here that the arrow at 2 has to be larger than the arrow at 1. So right here at 3 is now there's going to be a constant speed. Okay, so this is changing speed or changing velocity. So now I'm going to say that this is a constant velocity interval. Here's my question. Is the arrow at 3 larger than the arrow at 2? Look at the interval. See how the interval is longer between 2 and 3? So therefore, the arrow here has to be longer too. So what you're seeing here is that the arrows are getting higher or larger because you're speeding up here. Now I'm moving at constant velocity. So that means from here on now, this distance has to stay the same. So now if I continue to move at constant speed, then I'm going to draw my arrows so that they're all at constant speed here. Now look what I'm doing here. At 6, this is where she develops a cramp. So here's my question. Is the arrow at 6 the same, longer, or smaller than at 0.5? It has to be the same. Why does it have to be the same? Look at the interval. The interval is about 2 squares. So if I'm drawing all these the same size, then this arrow has to be the same size. Now we start to slow down. So if that's 2 squares, we're assuming that if she has a cramp, she's going to stop pretty fast. So look what I'm going to do here. So now at 7, I have to pick a smaller interval. So this is 6, this is 7, and then this is 7. So immediately then what do I see here? I see here that my arrow now is smaller. Ooh. Why is it let me be careful now. I did it at the wrong spot. Look at my interval now. My interval here is smaller. For some reason, something is making that erase. So then there's my smaller arrow because I have a smaller distance. And then if I look at my next dot, I'm going to say right here at 8, I'm going to say that this is where she stops right there. And at the stop, this is now the bus stop. And I think we should wrap it up.